For most of our history, humans have only been aware of one planet in the universe, Earth. It feels strange to modern minds, but knowing that there are other worlds out there is still a relatively new sensation for us. It's only been over the last few thousand years that we've really gotten to grips with it, identifying the likes of Mercury, Venus, Mars, Jupiter, and Saturn some 4 millennia ago, before a long gap in which our astronomical technology and know-how improved, until our telescopes could finally pick out Uranus for the first time in 1781, Neptune in 1846, and the dwarf planet Pluto in 1930. But of course, today, we know that all those planets, dwarf planets, and their surrounding moons and other objects are all quite close to us, since they're in our own solar system. So, exoplanet discovery, revealing planets in other star systems, is an even more recent phenomenon. In 1992, the first 2 confirmed exoplanets, nicknamed Poltergeist and Phobiter, were found revolving around a pulsar. And ever since then, exoplanet discovery has grown and grown. It's not as simple as just pointing your telescope in the right region of the sky and then spotting one, however. Most of the time, astronomers don't even see the planet they identify at first. Instead, a variety of methods are used to predict the presence of a massive body nearby. For example, most exoplanets are discovered via something called a transit method. This is the technique of watching a usually much larger star to see if its intensity dims at all due to its light being obscured by an object in orbit around it. Based on how much light is covered, scientists can then calculate how massive that orbiting object is, and thereby determine whether it is or isn't a planet. Another technique used is called the radial velocity method, where astronomers again watch stars first and foremost to see if their light becomes red or blue shifted, presenting a kind of wobble, which could be the result of a nearby planet's gravitational influence. Further methods for exoplanet detection include direct imaging and gravitational microlensing, which we saw in a recent video was also used to detect perhaps the most distant star ever found. But back to planets, and although some are used more than others, all methods have their own advantages and can be used to verify the findings of another. Nowadays then, we have plenty of bases covered, and although all these techniques require super advanced telescopes, we have an ever-growing fleet of cutting-edge, specifically designed facilities, both on the ground and in space itself. Using all these instruments and methods, NASA reached a milestone in exoplanet discovery midway through 2022, when it officially added the 5,000th discovered world to its archive. To break it down, many of those 5,000 were found by the Kepler Space Telescope, an iconic design launched in 2009 for the express purpose of discovering planets that revolve around distant stars. Kepler spent an eventful 9.5 years in space and uncovered thousands of planets and thousands of more potential planets before it finally ran out of fuel in 2018. In many ways, its mission is a model for how the search for exoplanets has unfolded in general. Because although 5,000 have now been confirmed by NASA, there are still many more suspected discoveries that haven't been verified yet. The verification process is long and intensive, with any one potential planet having to be shown by at least 2 methods of observation. The findings must then be published in a peer-reviewed journal, which can often take years. The Transit Exoplanet Survey Satellite, or TESS for example, has so far confirmed the discovery of more than 200 planets, but it's discovered more than 20 times as many planet candidates that are currently under review. So, although 5,000 is the official total number only just passed, we know that thousands more have likely already been found. We're just waiting for them to be rubber-stamped. If there's one thing that astronomers have learned from cataloging all these other worlds is that there's a huge amount of diversity in the types of planets that form. NASA has a categorization system that tries to break exoplanets up into 4 distinct types: gas giants, Neptunians, super-Earths, and terrestrials. Which category a planet ends up in is mostly according to its size and mass, but other factors are taken into consideration as well. Gas giants, in general, are massive, unsurprisingly gaseous giants about the size of Jupiter or larger. But there are various more distinct subcategories too. Hot Jupiters, for instance, are particular types of gas giants found so close to their home star that, according to NASA, their temperatures soar into the thousands of degrees. Neptunian planets are of varying composition, but are usually around the size of Neptune. They have solid cores and atmospheres that consist of only the most basic elements, but again, there are variations. Many Neptunes are much like other Neptunian planets, except that they're much smaller. Next, super-Earths are planets found to be very like our own, but they're much more massive. And lastly, terrestrials are those smaller, rocky worlds, like Earth, where it's thought that there might be water, and therefore a greater potential for life. There have been some even more distinct planets identified as well. The Unified Astronomy Thesaurus, an open-source database for exoplanet information, has further categories including pulsar planets, extrasolar ice giants, free-floating planets, and chthonium planets, which are gas giants stripped of their atmosphere and outermost layers. Some of the strangest exoplanets ever discovered have included unique features like glass rain, sideways rain, coal-black surfaces, 100% lava surfaces, and even diamond cores. But there are patterns to be found too. For one, planets seem to have a preference when it comes to their overall size. There are very few that exist in the range of between 1.5 to 2 times the size of Earth. This apparent gap is called the radius valley, or the photon gap, and researchers think that it could exist because there's a critical size that determines how a planet evolves. If it grows large enough, then it quickly moves beyond the gap, gathers an atmosphere, and becomes a gas giant. But if it doesn't grow large enough, it never pushes through that gap at all, and remains on the other side of it. And what of the search for life? The number of confirmed exoplanets that are located within the habitable zone around their home star with potentially perfect temperatures and Earth-like conditions has mounted up and up. Using information gathered from these worlds, scientists can today better estimate the likelihood of alien life in the universe. An important measure on the Drake equation, for example, is how many habitable planets there are out there. And now, according to projections made following confirmed observations, it's thought that there could be as many as 300 million habitable planets at least, and in just the Milky Way. We're a long way from officially registering all of them, but the first steps, it seems, have been made. Moving forwards, the technology is always changing. The Kepler is no longer in service, but more planets are continually being discovered by still operational telescopes like the TESS, and researchers are also looking to new technology to help in the search, including the recently launched James Webb Space Telescope, which is capable of studying even the precise atmospheric conditions of these faraway worlds. For now, 5,000 officially discovered exoplanets and counting is certainly something to celebrate. But compared to the number that are estimated to be out there, with suggested hundreds of billions, perhaps trillions in the universe as a whole, the work has really only just begun. We still have many, many more to find, especially as most of what we've spotted so far have also been the planets that are closest to us in space, and often just a few hundred light years away. Each new planet registered, however, is another subject to study and to learn from, another new world to explore. It's been a long and exciting road to this point, but there's plenty more to come.